Welcome to today's Video Bites from the Packet Pushers. We've got Nokia joining us as a sponsor today, and Erwan James is going to describe for us EQL, that is Event Driven Automation Query Language. So Erwan, we should start at the beginning. What is Nokia's Event Driven Automation?
Yeah, thanks, Ethan. Yeah, so Nokia EDA is our just launched and released data center infrastructure automation platform. We are just launched this a couple of weeks ago, and we are looking to automate and the lifecycle of all data center network infrastructure, but with initial focus on data center fabrics and data center networks.
Now, when I see event-driven automation, that tells me the network can see what's going on, and in reaction to things that are happening on the network, certain automations could occur?
Yeah, absolutely. Like one of the core principles of event-driven automation is, of course, that things can happen based on events. And events could be a multitude of things, right? An event could be a configuration change coming from, driving a new intent to the network, or potentially it's bottoms up. Maybe the event is actually a change of state inside the network to which the platform has to react, right? So events could be a multitude of things, but the idea here is that we're not sitting there waiting for someone to tell us what to do. We're reacting to events and we're reacting to change.
So Erwan, today we're going to focus on event-driven automation query language from Nokia. Give me the high level on what this is for.
Yeah, sure. So the EQL is basically for us to be able to query the entirety of the state of the network at any moment in time. And so for us, it's an ability to ask the network holistically information about it. So if you wanted to find out, for instance, how many interfaces are currently down, you could use the EQL language to retrieve that information from all the nodes. And we use streaming telemetry for all this. So we're not doing a mechanism in which we're polling the device, storing a database, and there's a bit of a disconnect between what may be in the network and what may be in our database. We're also not setting up probes ahead of time to discover what we should be collecting. This is all done live using streaming telemetry, as we'll get to in the demo here.
Okay, let's switch over to the demo. I want to see this.
Sweet. All right, let's do this. Okay, awesome. So just quickly set up the environment. This is the UI for EDA. I'm just showing a very simplistic topology that's been bootstrapped already. It has a fabric deployed on it, so it has proper configuration for a data center fabric. You can see here it has a few links that are up and down. I mean, that's on purpose, just for the purposes of this demo. But this is what we're working with. So you can assume that the devices have been ZTP'd, bootstrapped. We've pushed the fabric configuration, and now we're going to drop into the query language and the query tables to look and retrieve information from the devices. The EQL language is loosely based off of the GR query language for those who are familiar with it, but it allows us to kind of query, as I said before, the entirety of the network. And it has a language, it has a syntax that we have to use to do that. So I'm just going to walk you through, maybe how do we query BGP peers on our SL devices, our SL Linux devices, right? So the first thing we want to do is we want to start getting into the correct table of our database and our query language. So I'm just going to go and quickly get into .node, .srl, .network instance, .protocols, .bgp, .neighbor. Okay, so as soon as I hit enter there, it's gone and fetched all the BGP neighbors I have across the entirety of my network and is displaying them to me in this table, right? So as I said before, this is live query language. It's not going and going to a database to retrieve this. It's literally establishing a streaming connection to all the devices and then asking to retrieve the information and then live streaming it up into my table here.
Okay, so this is effectively real time.
This is real time. What we're looking at here is real time, exactly. Yeah. Now, one thing you'll notice is, for every given peer here, there's a ton of information, right? I mean, there's, the admin state, the peers, there's opera states, there's a ton of stuff here. And realistically,
a bunch of stuff that I probably don't want to know, depending on what I'm asking, what I'm really looking for. So, okay, I assume you're going to show me I can filter this.
Exactly. Yeah, exactly. Yeah. So we can say, what are we interested in? So we can say fields, and then I can specify what I'm actually interested in. So I'm probably interested in session state. That would probably make sense. I'm probably interested in the peer AS, maybe the peer address as well. And let's say last established, just for good measure. And if I press enter here, now it's exactly the same return data, but now I'm filtering it on just these fields, right? So I'm just displaying the stuff that I care about potentially, right?
Yeah, very clean now, and established as in, for those watching this who aren't BGP people, that means the established is literally that the session is established. You might look and say active. Oh, that's good. No, active means not established. We're still trying to figure it out, and it's not worked out yet.
Exactly. Well, and actually, you may, having said that, you may only be interested in the ones that are not established, right? Because really, if established, that sounds pretty good to me. I'm really looking for those that are not established. So you can keep it with your query language and say, further filter where, and I can say where session state, and I can say is not established. And so now again, I'm filtering and I'm getting all the BGP peers across my entire network. I'm showing the information that I care about, and I'm showing specifically the ones which are not established. And then I can take it one step further. I can say, well, that's interesting, but I'm really interested to see, I want to order them by last established. Potentially, I care about, the time at which, when was the last time these things were actually established? So I can actually continue with my query language, and I could say order by, and I could say last established. Let's say descending. And it's going to do the same thing again. And I don't know if we looked at enough detail at the query here, but we're actually ordering it by last established, right? Which allows us to really kind of get this information. And again, what we're showing here is the entirety of what's available, all the state that's available from any of our network devices and their exposed data schema, right? So in this particular case, I'm looking at the SR Linux data schema, and we know SR Linux is entirely model driven, right? So it's entirely Yang driven. So I can actually access any leaf, any state from the entirety of the device across the entirety of the network.
So that was a question I had for you. I think you just answered. On the very thing you begin this query with, .node, .srl, etc., that is a leaf on a Yang object?
Yeah, exactly. So starting here, so the beginning part here, which I've highlighted, is based in our database. So we're saying for all nodes that are SR Linux, and then when we start network instance, all this here is actually from the Yang model of SR Linux itself.
Got it. Okay. So then if I want to know what sort of objects I could query and pull, have EQL pull telemetry from, is there a schema that I can reference?
Yeah, so we obviously try and help you with some auto completion. You may have seen it as I was going through this, so I'll try and delete a bunch of this. So if I .neighbor, it actually tries to auto complete what's available for me here, right? So that's one way of doing it. So if you're not familiar with the schema, you can do this. Of course, we do publish our Yang models online as well if you felt like navigating through Yang, which I don't recommend, as looking at Yang is never super friendly as a human, but we try and make it human friendly by auto completing. Yeah, exactly. So this is kind of to help you, right? So we could say neighbor, and then I could look at maybe local AS specifically, and it would pull up the neighbors and show me the local AS numbers, right? Now, there's one thing you may notice. I mean, to what we just talked about, this is SR Linux specific schema, right? Now, our controller is multi-vendor, and when you use multi-vendor, obviously every vendor will have a different schema, and you may actually not be very familiar with SR Linux schema. So we do have abstractions, right? And on abstractions, we're able to collect the data from all of the different devices, and then we normalize it so that you can actually look at the same information in a normalized manner, right? And you can query that. So I could do something like .db, so it's a slightly different database table, right? But I could do .db.cr status, let's say .protocols, and I'll say BGP peer, and I'll look at BGP peer.status.
Okay, you got to explain a little bit what's going on here, because this schema that you're showing us is not, this is a Nokia specific schema that happens to do an abstraction that gives us some multi-vendor support, is what I'm understanding.
That's exactly correct. Yeah, that's exactly correct. And for those who have got a keen eye and maybe have touched Kubernetes before, you'll notice that we're using Kubernetes kind of nomenclature and terminology because, in fact, our normalizations are done through the Kubernetes model. So we won't go into detail there, but you'll notice here, for instance, I'm doing a CR status, and then this is the schema I'm looking in, and then I'm finally getting to the BGP specific, and then the status of it. And you'll see the return information is slightly different, but very much the same, right? I'm looking at BGP peers. Now they have names now, right? So you can see here, this is an ISL between border leaf 1.1 on this port and spine 1.1 on this port. But you get essentially the same information. We're getting that it's enabled. Now there's something called a health score. So because we're normalizing the data, we can actually do some more interesting things. We can collect state, and we can try and calculate what would be considered something healthy as not healthy. So in this case, we're saying, it's 100% healthy or it's 0% healthy in this particular example. So going back to what you said earlier with those who may not be familiar with, session state and BGP, well, this is a pretty good and simple indicator that something's good and something's bad, right? Like your health is not good, your health is good, right? And of course, you have the same information as we do. We do have the session state. We do have all the information that we were looking for, but in a normalized manner, right? So this is how you would query the information across the entirety of your network when using multiple vendors, potentially with EDA.
Can you show me things at the physical level. Like I'm interested in, I got a data center full of optics, and I'm curious to know if there's something that might indicate something's failing or got too high a temperature or something like that. Is it
Yeah,
just a matter of,
absolutely.
I suppose it's just a matter of what's supported in the Yang model, right?
Exactly. So for instance, if we go back to SRL, we could say interface, and then we're probably looking for interface transceiver, I suspect. Yeah, transceiver.
Yeah.
And then maybe you're looking for temperature. Now, this is in a virtual environment. So I'm going to do this, but you'll see there's probably nothing returned. Yeah, because I don't have
Yeah.
transceivers in this actual network. I'm using a simulated environment that I don't have transceivers. So that's why we're not getting data.
Okay.
But this is how you would do it, right? And then in the same way, if we normalize this, which we would do, you could get the normalized version of this across all transceivers, across all of your vendors.
So now, if I'm used to SNMP polling, like the olden days, I would poll on some minute interval, and then if something went beyond some threshold, I'd set an alarm. Can I do something like that here?
Yeah, absolutely. We do have alarms. So this is my alarm page, and you can set and you can define alarms and notifications based on the results of those queries. And so you can establish, say, I want to create an alarm, a BGP peer alarm, and this is the query I would use to monitor the session state. And then I would say, create a minor alarm based on it going to active or something like that. You would define the condition in which, but the entirety of the system is using that query language to extract the information from the network and then generate those alarms or potentially even some dashboards. You can create some UI dashboards, which are again using that same query language to extract the information from the network.
Does this mean SNMP is dead, Erwan?
I mean, we've been trying to say that for a while now.
Yeah.
With SR Linux, we have been banging the drum of streaming telemetry, and we found realistically that not many people are using the capabilities that streaming telemetry provides. This is one of the first platforms that I see in the industry where we're extensively using streaming telemetry. We're not using CLI scraping. We're not using SNMP. This is actually entirely done through GNMI, which allows us to do that go query the entirety of the schema across the entire network and retrieve the information extremely quickly, as you saw, and do it live, right? Streaming live telemetry. In fact, I can give you a little query. I have one just saved here because it does kind of highlight this point. I'm going to paste it in because it makes my life easier, and we'll talk through it. But what you're seeing here, and I don't know if it's going to show well in the stream, but there's an in and an out column, and this is counting and adding the entirety of the traffic across all my entire interfaces across my entire network. So
it's
what you're
showing
seeing
very
here
well.
is we're saying,
yeah. So it looks like it's changing in real time. Yeah.
it's in real time, exactly. So this is pretty crazy if you think about it. We're grabbing the traffic rate, which is called an NBPS and LBPS. We're summing it across every single interface across my entire network where there is some traffic. So we're excluding all the ones where there's zero traffic. And what you're getting is on the fly, we're streaming this from all the interfaces across the entire network, calculating it, and then displaying it to you live in this table. And this is kind of the power of streaming telemetry. This allows you to do these types of things. And then you can, of course, build your automations on top of it, whether those be dashboards, alarms, anything that's event driven. Consider each one of these events.
It's the power of streaming telemetry, but it's also the power of the query language here, because I'm getting the opportunity to do data manipulation and then present a pre-calculated result. That's
exactly.
There's a lot of power there.
Now, I would say, we've been talking about the query language. You've seen me kind of type it in, and I've also gone as far as pasting one in, because there's obviously a bit of a learning curve to the query language, right? You have to either understand the schema of the devices or potentially our normalized schema. And then beyond that, you also have to understand what you're able to filter on. You could do sums, you can do counts, and so on and so forth. So it would be a bit strange for us not to, in today's day and age, include a natural language version of it, where I can actually ask it in natural language, where it will convert it into the EQL and then execute the same query. So I could say something like, show me all interfaces. Yeah, go ahead. Sorry.
Okay, so you're going to run this natural language query, but it's going to build an EQL query, is what it's going to do. It's not.
Exactly.
Yeah. Okay, I see. So the input ultimately still needs to be an EQL, but I've got a natural language processor that I can use to help me figure that out. That's very cool.
Yeah, exactly. So you can see here, I asked it to show me all the interfaces that were opera up and admin up, right? So this is just, again, and you can see right below it, this is the query it executed in the background. So it's gone and figured out what the query is, and then the data returned is from the query, but it actually went and figured it out. So, and then you can expand on this. You can do some pretty cool stuff with the natural language, especially when you don't quite understand the query language. You could do things like, I'm going to paste a couple commands in here just to make my life easier. What can I type it in? Show me all interfaces with error counter, and then type things wrong, but that's okay. The AI overloads will correct that for me. Error counter above 0. So now it's showing me that I have one interface, my management interface on leaf 1.7 is a error counter above 0. Now it's showing me my end octets and all that, but maybe I only care about only show me the error packet count. That should be enough. And there you go. So it's the same output, and it's showing me just the in error packets. Of course, there's only one error packet apparently, and it's not incrementing, so it makes it less interesting. But it's gone and figured out, the fields it should filter on, and then the condition which would trigger this particular query to return information.
Erwan, where is these queries running? I'm logged into a switch somewhere? What's happening here?
Well, the queries are running locally. I mean, I'm not sure how to answer that question. The queries have been executed from the controller, and the controller is figuring out which nodes it needs to talk to. In this particular case, it's actually talking to all nodes because I haven't filtered on a specific node. So it's actually asking every single node if any of their interfaces have an error counter above 0. And this is the only one that returned an answer was leaf 1.1.
Well, the magic here is that we're talking about, we're thinking about the network holistically. It's a fabric. There's a controller that is the overlord of the fabric, and we're talking to that controller that can then talk to the individual network elements and give us our answers, pull the streaming telemetry from the nodes that it needs to pull from, and so on, which is actually even a little more remarkable about how fast it is. Because wouldn't it, if you ask it a query and we're pulling streaming telemetry, is that coming off the controller or the end nodes or both?
Well, it's a controller asking the end nodes, and the end nodes are coming back and responding, and then the controller is displaying that in the UI for you. So that whole sequence is happening as fast as you saw it happen, right? I execute if I put another command here, if I ask it which node has a subinterface with this IP address, right? If I do this, so what's happening, like in the time that it's saying loading here, it's going and querying the entirety of the network. So every single node is getting asked the same question by the controller. And the only one that returned with correct data is leaf 1.8 system interface system 0. Subinterface 0 has this particular prefix on it, right? So but all that is happening in the time that you saw it while it had a little loading screen there.
Basically instantly, yeah.
Wow. Yeah, instantaneously, exactly. And you can do, you could do some other interesting stuff. You can ask it questions like, list me all nodes which are running version below 24, 24. Let's imagine you need to figure out which nodes are running a software below a specific version. In my case, they're all running below 24 because they're all running 000. That's our engineering build. But this would be how you would go and ask it for a list of nodes that are running a specific version or below a specific version if you need to figure out which ones need to be upgraded because of a potential security patch, right?
So, Erwan, you've showed me some layer 1 stuff. You showed me some layer 3 stuff. What about layer 2?
We can do that as well. One of the things that we get often is, where was this MAC address learned, right? You can imagine someone's spun up a virtual machine or a host on your data center fabric, and all they know is the MAC address of it, and they're expecting you to figure out on which switch and which port that was learned from. So you can query the entirety of the network to figure that out, right? So I'm just going to copy paste again just to make my life easier, but we'll go through the command. You see here, on which VLAN was this specific MAC address, assuming that's the one that was given to me by my compute team, and then show me the interface on which it was learned. So I can hit query here.
Okay, so we found that MAC address on Ethernet interface 112 of leaf node 1.1. Okay, and again, we queried the whole network, a whole bunch of different switches, and found it. That's where it is. All right.
That's where it is.
Well, the question's VLAN, right? I also want to know what VLAN it's on.
Exactly, yeah. So obviously it didn't return with the VLAN, so it got it correct. It found the node, it found the interface and the sub-interface, but we can say what VLAN is on interface Ethernet 112 sub interface 1 on leaf 1.1 specifically. And it can come back and tell me that there it is, VLAN 81, right? So we can, again, you can just interact with it like you normally would with any generative AI system. If it doesn't return the information you need, you're able to continue and keep asking a question until you get the information you're looking for.
So from a standpoint of the people that are using this, do they tend to stick with the natural language, or do they tend to learn the query language itself?
I think the reality is that you probably start off with natural language because it does give you kind of because it's showing you the actual query language. And if you just switch back to the EQL, it allows you to edit it. It's a great learning tool. It's a great quick answer this question if you can. Show me the query executed, and maybe you refine it, right? So maybe then you jump into the EQL and you kind of refine the filters or the condition in which you want to match. But usually you would say natural language first. I think a power user who spends enough time with a query language will find that the query language probably is a faster way for them to get the information they need when they need it. But yeah, I would say probably natural language, get that while you're learning EQL, and then as a power user, you probably switch to the EQL.
And it's going to be like a lot of things. Once you've typed those commands in frequently enough, it's muscle memory. You know exactly what you're looking for, and it comes out quickly, and off you go.
Yeah,
Pulling
exactly.
the information that you want. Yeah.
Exactly. And we have autocomplete, like I showed you. So like there's tools we have there to try and help you figure out what the next thing is that you want. But certainly, muscle memory. You do it, the more you do it, the faster you get, and you become that power user.
So Erwan, thanks for the demo of Event Driven Automation Query Language, EQL, from Nokia. Now, if people want to find out more about this, where would you send them?
So you can head to nokia.com and search for Event Driven Automation.
Excellent. Thank you very much.